Hello students, today we are going to study this problem which is based on work energy principle. So the question statement is the 3 kg smooth collar is, here we have to write one word which is a collar. The 3 kg smooth collar is attached to a spring of spring constant 6 Newton per meter and the spring has unstretched length of 2.8 meter. Determine the speed at A when it is drawn to point B and released from rest. So in this question statement you can see there is one spring which is kept at point B and it is at the rest condition when it is at point B. When it is released from point B, what will happen? As the spring is stretched, it will try to unstretch. It will try to come back to its original position, and in that process this collar which is a very smooth collar which is assumed in the question statement, it will move from point B, it will try to come to point A. So when it is reaching at point A, we have to calculate what is the velocity of this collar at point A. So this problem we have to solve by using a work energy principle. Okay, so first of all let us consider that this given condition of the system is a stage 1 of the condition. This is a given stage which is a stage 1 where we are keeping this collar in a rest condition. So what will be the velocity? Initial velocity of the collar will be equal to 0 because it is in the rest condition. Because of the rest condition, its velocity will be 0. And what will be the kinetic energy? Kinetic energy at this condition 1 will be equal to 1 by 2 into mass of the collar into u square, which is equal to 0. As u is 0, kinetic energy will be equal to 0. Now let us consider what is the length of the spring in a given condition. Now you can see this length is 4 meter and this vertical length is 3 meter. So there is a 90-degree angle is formed over here. So this length, let us assume this point as O. In this right angle triangle we can write OB square, which is equal to 3 square plus 4 square. So OB square is equal to 9 plus 16, which is equal to 25. So automatically this OB length is equal to 5 meter. If we take square root of this, which is OB is equal to 5 meter. So this is the length of the spring in a stage 1. Now as the length is equal to OB is equal to 5 meter, what is the deformation of the spring? We have to calculate the deformation of the spring. Deformation of the spring is equal to, let us say x1. Let us say x1 is the deformation of the spring at stage 1, which will equal to OB minus unstretched length of the spring. Unstretched length. Okay, unstretched length of the spring. So OB minus, what is the unstretched length of the spring? It is given in the problem statement. It is 2.8 meter. So OB minus 2.8, OB which is 5 meter. So 5 minus 2.8, which is equal to 2.2 meter. So x1 we have, x1 is equal to 2.2 meter. So why we are calculating the unstretched length of the spring? Because to calculate the spring work done, we will require this value. Now when we release the spring, we release this collar from this point B, it will slide along the bar and it will come to point A. So stage 2 of the system will look like this. See, this is this support, hinge support, this support is there. This spring will come over here. This is the given rod. This is a given rod. And the collar will be over here, and it is the length of the collar. This is the length of the spring. This is the length of the spring when it is reaching at point A. So when it will reach at point A, consider V is equal to velocity at stage 2. At stage 2, let us assume that velocity is V and its deformation is equal to current length over here is 3 minus unstretched length is 2.8. So it is 0.2 meter. So we have calculated two parameters at every stage. At stage 1, initial velocity u is 0, kinetic energy is equal to 1 by 2 m u1 square, it is 0. This length is 5 meter. So current length is 5 meter minus unstressed length which is 2.8 meter. So deformation x1 is equal to 5 minus 2.8, 2.2 meter. When it is reaching at point 2, its velocity, let us assume that v velocity, because we have to calculate that velocity. The length of the spring over here is 3 meter, and then again we have to subtract this value 2.8 meter, that is a undeformed, unstressed length of the spring. So 3 minus 2.8, 0.2 meter. Now by using this data, we have to calculate the velocity v and we have to apply the work energy principle. So first of all, let us calculate change in kinetic energy. Change in kinetic energy, which is equal to kinetic energy at point 2 minus kinetic energy at point 1. What is kinetic energy at point 2? So let us write this change in kinetic energy as delta Ke. It is 1 by 2 m v square, because velocity at point 2 already we have taken as v. So 1 by 2 m v square minus 0. Why 0? Because kinetic energy at point 1, you can see it is 0. So 1 by 2 into mass of the collar, it is given, it is 6 Newton. Okay, not 6 Newton, 3 kg. 3 kg is the mass of the collar. So we have to write 3 over here into v square. So delta Ke is equal to 1.5 v square. Okay, so this is a change in kinetic energy. Let us write this as equation number 1. Now let us calculate the total work done. Now what is work done? Work done in this system is equal to, only because of one thing, that is because of this deformation of the spring. Only spring is doing work in this question, in this system. So work done by spring. Only one work done is there. It is given by 1 by 2 k x1 square minus x2 square. This is the formula to calculate the work done by spring. 1 by 2 k x1 square minus x2 square, where x1 and x2 are the deformation at point 1 and at point 2 respectively. So 1 by 2 into k is given 6 Newton per meter, into x1 which is 2.2 square minus x2 which is 0.2 square. So this total quantity, if we calculate, okay, this comes out to be 14.4 joule. We get this value as 14.4 joule. So we are getting work done is equal to 14.4 joule. Let us write this as the equation number 2. By work energy principle, we can write change in kinetic energy is equal to total work done. So what is change in kinetic energy? It is 1.5 v square and work done is equal to 14.4. So if we calculate this, we get velocity v is equal to 3.098 meter per second. This is the value of the velocity we are getting, and this is the velocity of the column at point A. So this is how this question will look like. Thank you.